Right, so we made a laser shooting gallery. We basically miniaturized a carnival game. Our 5 targets in here are photodiodes, so they react to the laser pointer that we have. 3 of them are attached to a 4-bar linkage, which is controlled by this motor right here, and then 2 of them are static, and they're just these stars in the background. We have 2 modes to this game, easy and hard. Hard mode, every time a sensor on the 4-bar linkage is hit, the motor will change speed and change direction. It's kind of randomized, so about 50% of the time it changes direction, and every time it changes the speed, either higher or lower. And then easy mode, every time you hit a sensor on the 4-bar linkage, it changes speed. It just gets higher and higher and higher every single time. And so yeah, we have this LCD screen right here that will tell you which mode you're in. There's a little welcome screen, and then it will display the high score, which right now is 0. And then every time, this is our start-stop button. So we'll start playing it in a second and demo that. We have 2 speakers at the bottom that both play a constant carnival music, and every time a sensor is hit, they have a reaction noise. And then this LED strip has this continuous color change happening, and then every time a sensor is hit, it also reacts by flashing a red light. So we'll start it. And then this LCD screen also counts down 60 seconds, that's how long the game is. And then it will display the score at the end, and then keep track of the high score for that round. Alright, so that's how it moves. And so you can see it change direction, change speed. We'll hit a static one. Also, the score is 10 points for the moving sensors and 1 point for each static sensor.
Because the 4-bar linkage sensors are so hard to hit, we wanted it to be worth a lot more than the static ones. So you still would win a game, theoretically, against your friends by hitting the moving targets versus just constantly hitting the stationary ones.
So right now it's displaying game over, and then our score was 65, so the new high score is 65. And then back to the welcome screen, music turns off, and the high score stays at 65 until the game is turned off. It doesn't really have a memory after the game is turned off.
So we really consolidated down as much as possible. So we're running all of our components almost off this single breadboard, with the LEDs taking up the middle of it with a PIC, and then 3 MOSFETs to associate with the colors and whatnot. The sound chip is here at the end, connected to the speakers. That is a 2 megabyte flash on it, so you can program it just simply from your computer by dragging sound files onto it, making it really easy to run simple sound effects and whatnot, as well as the carnival music will continuously play with a couple different functions on it. The Arduino is using almost every pin, if not every pin, maybe 1 left over. Even the analogs are used because we're running the LCD as well as every other system off of that. It's leading communication between the PIC and the Arduino, as well as the sound chip in the Arduino and the LCD. All of our powers are based off of this single wall outlet that goes to 3 converters here. The LEDs draw a lot of power and amperes, so we have one dedicated simply to those, as well as one dedicated to the motor because it runs best off of 6 volts just continuously going into it, and then one powering the rest of the system here. As well as the LCD has our contrast and whatnot for the potentiometer also built in on this consolidated board here, really freeing up a lot of space for if we wanted to add anything else to it. The construction was fairly simple, a lot of screws and wood that we worked ourselves and formed into what shapes we needed. And then the artistic license was whatever we wanted it to be.